All right, so we are going to do 5, 5. Oh, you'd like to see it. You would like to see it. All right, so we've talked about this a little bit, and we've done some of the integration, but now we're going to get some that you cannot do the regular way. The rules aren't going to help you, and these are not definite integrals, so you're not going to be able to do them on the calculator. You're going to have to show the work. It's really important. I spoke to someone who's taught Cal 2 a lot and said use substitution is important. It's good that they get it, so it's worthwhile. Evidently, you're going to see this again. So, the deal with using substitution. You'll see things inside the integral that look like, okay, I don't know how to take the integral of that. Something like this, where it's a product, and you can't multiply this out very easily. Why not? Because this guy's raised to the 5th power. You can't ignore that. So what we do is let u equal part of that problem, and then we're going to make a substitution, kind of like I showed you those two things on Tuesday. So what you want to look for, the things you want u to be, are things that are raised to powers, things that are in radicals. Those are some things that it makes sense to let that be u. We're going to practice enough that you'll be a little bit more familiar with it. Okay? So the process is, okay, I've got this, and I see this thing is raised to a power. So I'm going to say let u equal that thing. Not to the power, just that thing. Then you go ahead and take the derivative of what you said here. So if this is u, du is 3x squared plus 1 dx. Does that make sense? I just took the derivative of whatever I let u be. Then you make sure that what you've got for du is accounted for here. Does that match exactly? Okay, so I've taken care of this part, and I've taken care of that part. I've accounted for everything in my integral. So now I'm going to rewrite what I've got. So I can say, well, that's the integral of u to the 5th, because that thing was to the 5th, du. And then I've accounted for everything that was in the original problem. This is easier to take the integral of, right? We know how to do that. That's u to the 6th over 6. So you do that plus your c. Once you get the integral, then you just substitute back in whatever u was. So your final answer would be x to the 3rd plus x, that was u, to the 6th over 6 plus c. Does that make sense? No? Okay. You're taking the integral of this just like in the original problem. That just says this was a derivative. It's actually a differential that's called. And so we can't just arbitrarily say, well, I'm going to write this as u to the 5th du. It all has to match. And we found du could be written instead of this. So it all has to match. Okay? All right. The rewrite, okay, down this part, that is just taking the integral of u to the 5th. Add 1 up here and divide by that same number. So this is the answer, except we haven't substituted back in. Okay? Yep. All right, let's try this one. The integral of square root of 2x plus 1 dx. Again, we've got something in the radical. That's your clue. So we will say u equals 2x plus 1. So du would be what? 2 dx. Do I have a 2 dx here? No. So that says, oh, wait a minute, you got to do a little bit more work. Divide this 2 out. So that makes it 1/2 du equals dx. Now do I match? I've got u taken care of right there, and I've got dx, and I'm good. But I've got this 1/2, so when I rewrite, that 1/2's got to be in my problem. But since it's a constant, what can you do with constants? Pull them through the integral sign. So when you rewrite your problem, you can write it as 1/2 the integral of Why do I have u to the 1/2? Yeah, so u to the 1/2 du. And I've taken care of everything. Is this easier to integrate than this? Sure. So u to the 1/2, the integral would be u to the 3/2 over 3/2. And then I've got a 1/2 out here. 1/2 times 2/3 u to the 3/2 plus c. Go ahead and multiply that out. You get 1/3 u to the 3/2 plus c. And at that point, you substitute back in. It is a way, it's a technique to do things when we don't have a rule that works for us. Typically, you're going to leave it like this. Oh. I think we'll, if it's something weird, if MathLab, I think I've noted that in the problems. For me on the test, this is perfect. Yeah, but I think I've noted what the answer should look like in MathLab. Okay? All right, let's do a trig one. All right, the integral of secant squared 5t plus 1 times 5 dt. All right? The argument in trig is very often what you want to let u be. So if I let u be 5t plus 1, and I know we hate the t's, but is that any better? I don't know. And you take the derivative of that, it's 5 dt. Well, that matches perfectly. I've taken care of that, and I've taken care of this. So now I'm ready to rewrite, and I have the integral of secant squared u du. Do you have an integral rule for secant squared? Tan u plus c. So once you have that, then tan of whatever u was plus c. Did I put it in handouts? Probably not, because I think I just created it. I'll print you one, and I can do that before you leave. Okay. Well, anytime you take the integral, this du, anytime you take the integral, that's going away because you're going from derivative back to derivative. Okay. All right. And I put this in here. I don't actually think I gave you any in the homework, but it said, and this is a trig thing, but integrals of sine squared x and cosine squared x, you could sometimes use these substitutions. So you might write that down. I don't think I gave you any with that. We'll double check that, but just for future reference, you could maybe use that, and maybe it would be okay, better. Okay. And yeah. All right, so I think we're ready to do the problems, and I did give you about 13, which I know that seems like a lot, but you really need to practice these. Sorry. Okay. All right, can you see that at the back? Okay. You can see that? Okay. All right, so let's do this one. Evaluate the following by doing u substitution. Sometimes as we start out, okay, so this one, especially the ones as we start out, tells you what u should be. So if u is 3x plus 9, what is du? 3 dx. Do we match? Because we've got that and that, and we'll make that there. So then we're going to rewrite. So what's our problem now? U to the 7th du. And so the integral of u to the 7th is what? Plus c. Okay.
So the 3 just does itself.
Well, you got it taken care of in the original problem. It was here, 3 and dx were there, and we're saying du is equal to 3dx, so it counts. Okay? All right, and then you would just substitute in, and so whatever u was, wherever it was, I can't see. So we have 3x plus 9 to the 8th over 8 plus c. And I think for Math Lab, because you were asking about that, Drew.
Yeah, it'd be like having a 1/8 out.
Yeah.
Well, I would figure they probably want like you voted originally.
I think this is what they want.
Oh, okay.
I'm thinking. So guys, pay attention to that. I think this is what they want. Try that first. It may be that they take either way, but that might be. Okay? Yeah. I don't know. It says expiring?
Yeah, it does that for every course.
Oh. Okay, I don't know. All right, now, remember that with these trig ones, you want to usually or often let the argument be your u. So you would say u is 2x. What would du be? Do we have a 2 in the integral? No. So we're going to divide that 2 over here and say, well, 1/2 du is dx. And so now we're good. We've got a u. So how would we rewrite our problem then? 1/2 the integral of sine u du. Does that make sense? All right, and so our answer will be 1/2 and what? What's the integral of sine? Negative cosine, so I'm going to throw a negative there. Cosine, I'm going to go ahead and substitute. Well, I'll do it in 2 steps. So negative 1/2 cosine 2x plus c. Okay? I think it's the integral of sine, I think, is negative cosine. Isn't it? Okay. Okay. Uh-huh.
Unless sine is negative, right?
It would have been.
You see, it messes with your mind. Yeah. All right.
Otherwise, it would have been negative sign.
Yeah. Yeah. Okay. The very first thing I would do before I did anything or thought about this one would be to take the 27 through. I would pull it through the integral, and you would have secant 3x tan 3x dx. All right. So what would I let u be? 3x, because that's the argument. That's the smartest thing. What is du? That's what's the derivative. 3 dx. Do I have a 3 dx? No. So what do I do? Yeah. So 1/3 du is equal to dx. So now when I rewrite, yeah, I'm going to write it both things just because so we can see it. That's all out. And then I have what? Secant u tan u du. That's a bad secant. Okay, does secant u tan u have a, is there an integral rule for that? What's the integral of secant tan? Just secant? So we would have 9 secant u plus c, so 9 secant 3x plus c. And I don't know if they put that in parentheses or not. Maybe. All right, everybody good? So typically we've seen a couple of things. We've seen when you have a radical, let that be u, whatever's in there. When you have something raised to a power, or when you have a trig argument. That's a typical strategy. Okay? All right. This one looks really, really ugly, but they told you what u was. So go ahead and pull this 30 out. Pull it through. You have the integral of s to the 5th ds over the square root of 3 minus s to the 6th. All right, and it says let u be that. So if u equals 3 minus s to the 6th, what is du? Is that?
Would this be u divided by -6?
Yeah. Yeah, because look here, we don't have this 30 anymore, so what am I missing here? Because I've got ds. I don't have a -6 here, so let's get rid of the -6. Divide it on the other side. So I have -1/6 du equals s to the 5th ds. When you took the derivative here. So we match this with this, and I guess I don't need that out there. All right, does that make sense? You have to make sure that whatever's left besides the u has got to match to what you're letting du be. All right. I divided by the -6 over here, which became -1/6. You divide by 6, it's okay. And so when I rewrite, I'm going to have the 30, and I'm going to have the -1/6 outside. So rewrite, and we have -1/6 times 30 times the integral of, and what do we have? We have u, can we just write it u to the what? -1/2 du. Does everybody see that? Because this is u to the 1/2, but it is on the bottom of a fraction, so we're going to make it a -1/2. That's going to be easier for us to deal with. What is the integral of u to the -1/2? U to the 1/2 over 1/2. So this is going to be -5 u to the 1/2 over 1/2 plus c. I need a little bit more room. So we got -10 u to the 1/2 plus c. And then we're going to put our u back in. What was our u? Yeah. And was the original in fractional exponent? It's a radical. Oh, here was a 6? Yeah, I just, see, I can't see the original. Okay, sorry. To the 1/2. Okay. All right, so you could, and I don't know what they're going to say, but it could be 10 square roots of 3 minus s to the 6th plus c. I am not sure what it prefers. So, whatever the problem was. All right. Okay, let's let you do that one because they're not telling you what u is or anything. Let's try that one. Well, do you have that so far? I haven't plugged back in.
I got 2 over 21 times -6 plus all that.
3 halves.
Plus c.
So a lot of these answers look like, wow, surely I could simplify that, but sometimes there's not much you can do. Any questions on that one? Is that working? Are you good, Lee?
Yep.
Nope? Oh, you're good. Okay.
I can get to all the way to the 1/7 d u equals ds part, but I don't understand what you do.
You understand? Okay, let's kind of backtrack here and make sure. So in this problem, you got how to let u be that. You got how to take the derivative of that. You need to match this 7ds has to be present in the problem. And I don't see a 7 outside this radical, right? So I got to get rid of it. I divide it over here, and I'm left with ds. Now I match. Like here and here. So you got that, okay? So then you rewrite your problem, and whatever this number is here, it's going to go outside your integral sign. 1/7, and I'm going to let this be u to the 1/2, because whatever was u is inside that radical. And then you just take the integral of it like we know how. Is that better? Okay. Let's try this one. This one's a little bit different. Trying to give you several different kinds. All right. Let's let u be 16 plus x squared. So what's du? 2x dx. So you look back at your original problem. I have x dx, which is great. I don't have the 2. Divide it. And so now I've got what I need. Everything has to be accounted for. Okay? So now rewrite your problem. The 1/2 outside, integral of, what is it? What's going in here? U to the 1/3. Because this is a cube root thing, there's a 1 around the whole thing that's inside, so it can be 1/3. Okay? And then what is the integral of u to the 1/3? So we got 1/2 times u to the 4/3 divided by 4/3 plus c. So when you have this fraction down here, it's going to flip. You got 1/2 times 3/4 times, what was our u? 16 plus x squared to the 4/3 plus c. So 3/8. Once you get the process down, it's not so bad. You know, you just have to make sure that you've accounted for everything in the original problem. I didn't write it down that way, Keith, and I'm not positive. Nobody has a laptop that's going. If you wrote it like this, it's going to, if it's absolutely crazy about the format, it would tell you that. But I tend to think it's going to be okay. You would have the cube root of 16 plus x squared to the 4th. The denominator here goes in the index here. Okay. All right. Okay. Now you're ready to try that guy on your own. He's a trig one, so let's try that. Or the argument of a trig function. Okay, those are your 3 main things that you're going to look for. And then And we're going to rewrite 1/8 integral of cosine u du. And what's the integral of cosine? Is it plain sine? I don't know. I think I threw a negative on there. If you have my notes, that may be wrong. So, okay, well I'm listening to you. The integral of cosine is negative sine. Do you have it? That's what I was saying. I think it's wrong on my sheet. Oh, not that sheet. My note sheet.
The
Derivative of sine is cosine. So we have it written right here, so you can correct that. If you look at my notes online, it's wrong there. There's a little negative thrown there, just for you. Okay, so 1/8 sine of what? 8z minus 3 plus c. Okay. All right, we good? No. I mean, if you get a process down, it's always good. You know, if you can get a process. Yes? Well, when you have a du or a dx and it's inside the radical, I think that's what Lauren asked before, you're taking the integral of that and you're trying to get back to the original function so the du goes away. All right. Let's do this one. This is what's raised to a power, so if u equals r cubed over 12 minus 8, I would write that like this then. It's easier to take the derivative if you have it like that. So I'll write it one time here. 112 r cubed minus 8. So what would du be? 3/12 or 1/4. I'll go ahead and write it as 3/12 r squared dr. Okay. Do we have an r squared dr, but we don't have this 3/12 or 1/4. So if I got to get rid of the 1/4, what's it going to become over here? 4. So 4 du is equal to r squared dr. Bless you. Do what, Mitchell? Question? You're dividing. If you're dividing by 1/4, it's the same as multiplying by 4. Okay? So, question? Anybody else? This 3/12. What that sound? That 3/12 is 1/4, Delana. And so we're dividing by 1/4 and it becomes 4. Okay? All right. So we're going to rewrite. Questions?
116 r cubed over 12 minus 8 is now 4 plus 3.
Hold on. Okay. So the integral, we have a 4 out here. The integral of what? U cubed du. What do you get when you take the integral of u cubed? Okay, do you see what you did?
Yeah.
Okay, so you actually just have u to the 4th plus c. And your u was that business, so you've got r cubed over 12 minus 8 to the 4th plus c. It's easy to make little mistakes like that. You want to be careful. Yes, sir. I think actually it, oh, well, I don't have it written there. Maybe,
It was only on that because.
I think it just got, I think it got cut off by that line thing. I think because I did it right.
Yeah.
I mean, I have my notes. I've got them.
You had all that right, but like you.
I think you see that line. I think
Oh,
it's cutting it
okay.
off. So I think that's fine.
Kind of like,
Don't, I don't know what you're doing with that line.
No, the interval will print.
Okay. Oh, do you still looking? Sorry.
yeah, I'm just trying to figure out the.
Okay, this part or what? Right here?
Yeah, where'd you go from? Oh, you just plugged it back in, okay.
Right, and these canceled out, Lee, the fours,
Yeah,
and
I
so
got
you just
that.
had u to the fourth.
I just didn't realize you were plugging it in.
Okay. Well, you know, that happens. All right. Can I move up?
Yeah.
Okay, that's all right. Okay, we got the integral of t to the 8th times 6 plus t to the 9th, all of that to the 7th dt. So what are we going to let u be? All right, and then du would be dt. Do we have a t to the 8th dt? Yes, we don't have the 9. 1/9 du equals t to the 8th dt. And so now I'm good. Is that getting better? At least, figuring out what u is in du and being able to rewrite. That's good. That's good. All right, so we're going to rewrite, and we're going to have 1/9 times the integral of u to the 7. You know, I said 7 and wrote a 4. I'm wanting to be to the end of the problem, I think. Okay. You're writing it as the original. Yeah, yeah. So then we have 1/9 u to the 8th over 8 plus c. So 1 over 72 times, and I'll substitute back in, 6 plus t to the 9th to the 8th plus c. And maybe it would look better like that. It would show you better. All right?
Why did you show us the name and
Look at your original problem.
okay.
Did you see? I can't, I'm trying to move it. Okay. All right. All right. Now this one, you got to do a little bit different. If you had calculus in high school, you may have encountered a problem like this where you had to do a little bit different substitution. There's just one of these, but it is worthwhile to have seen one and tried one. Okay. Typically, we would let what's inside the radical work for us. U equals x minus 2, then du would be just 1 dx. But that didn't really help me because I've got an x up here. I can't just arbitrarily do something. So when that happens, you want to say, well, if u is x minus 2, let's solve for x. In this little equation, x would be equal to what? U plus 2? Okay, does that make sense? Just doing that so far. So I could rewrite now u plus 2 over the square root of u du. May not look like it's going to help, but it will. All right, I'll let you get that written down, or at least attempt to process that. We can separate this now into two integrals, okay? We can have the integral of u over the square root of u du plus the integral of 2 over the square root of u du. How could I write that so that it isn't a fraction? 2u to the negative 1/2. Does that work? And could I write this one not as a fraction? U to the 1/2, because you've got u over u to the negative 1/2. I mean, over u to the 1/2. Sorry. All right, and so to write it as one thing, what would it be? It would be u to the 1 minus 1/2, so it would be u to the 1/2. So, and now I have integral of u to the 1/2 du plus integral of 2u to the negative 1/2 du. Can we do both of those? Okay, what's the integral of this guy? Okay, u to the 3/2 over 3/2 plus c.
How is that one positive then? That one negative?
I just brought this one to the top. When it came to the top, it changed from positive to negative. If I leave this one on the bottom, it's still positive there. Yeah. Okay, so let's do this one here. What's the integral of this? 2 u to the, you're going to 1/2 over 1/2 plus c. Okay, so what's this one? We got 2/3 and u to the 3/2 plus c plus, what happens here? 4 u to the 1/2 plus c, and now we're ready to substitute back in. Do you remember what we what was u? X minus 2. So we got 2/3 x minus 2 to the 3/2 plus c plus 4 times x minus 2 to the 1/2 plus c. Do what? You could put it all like in a bracket and say plus c. You wouldn't want to just the c's. I think I'd write it like this. You're all right with leaving it like that? The only way that I would rewrite it differently might be to put all of this in brackets plus c at the end. But I think this is fine to do this. Okay, you have one of those. One of those. Okay. I didn't. Not on this test. Final's always up for grabs. Haven't done it yet. There's not going to be one on this test. I said that. Oh, on the final. Could be. I don't know. You don't want one? Okay. All right. Okay. You try this one. Okay, so this is probably cool. You got this. How would we rewrite this problem then? U to the negative 2. And why is it u to the negative 2? Because it's on the bottom. Oh, sorry. Yes, look. Good. All right, so the integral of u to the negative 2 is what? To the negative 1 over negative 1. Okay, so what's going to happen here? It's going to be a positive 1/5. And then u to the negative 1, we could write it like that and say 9 minus x to the 5th to the negative 1 plus c. Or how else would we write it? I am not sure what's the preferred way, but we've written both ways there.
Oh no, if you use the negative 5 instead of 4px,
Mm-hmm.
bring the negative 1 bits out.
Right.
What is that negative in my positive? If you divide it by
You divide it by negative 5. So negative 5 into a positive 1 du. Where are you thinking it should?
well, I'm thinking, don't you have to divide the right side by negative 5?
Yeah, so this is positive then, but this is
Oh,
negative.
okay.
Yeah, that's okay. All right. Everybody good with this one? Did I resume? I did. Okay. Okay, go away. Now I have a bunch of dots. I just can't make it go away. Okay, minimize. Thank you. All right. Number 12. Does that look fun? Yay. All right. Evaluate this integral. What would be the one thing that I could start off with doing? Before we let you pull the 2 out. So this could be 2 times the integral of 1 over 2x minus 4 ln 2x minus 4 dx. Okay?
What's the point of doing that? I mean, I understand that you can pull apart some theory.
Sometimes it's easier to see what you got, and it just makes it a little easier to
'Cause
start
anyway, I'm
work.
looking at it, still a fraction.
Yeah, but you don't have to worry about accounting for that 2 now. You don't have to worry about substituting. He's already outside. Okay? All right. All right, what would you let u be? Well, let's think about this, because you would try it maybe, and if you said, well, if u is 2x minus 4, what's du? 2 dx?
So it'd be easier not to pull it out.
No, but I mean, but you still have this. You haven't accounted for that. So what if we let u be ln 2x minus 4? What's du? What's the derivative of ln? Isn't it what? Okay, so it's u prime over u. So would it be 1 over 2x minus 4 times, well, the 2 would be, I guess, up here, and you'd have dx. So, do we have, what have we matched? We've matched, I did that the wrong color. Okay, so you could leave the 2 and you'd be fine, but what do we get? If I did this way, because I always do it this way, what am I going to have to do? Well, divide by 2, so I'm still going to have, I'm not writing in yellow. And so now have I accounted for the, well, I should do it here, because I did that not even thinking. So I've accounted for this, and this, and this. And this was my u. So did I take care of everything? I could have left the 2. I guess I get used to pulling that through. In this case, it worked out fine because it matched the numbers, but what if it had been a 5 or something like that? So we're good. All right, let's rewrite the problem. We got a 1/2 integral of, oh, so we end up with 1, right? So they cancel out, sorry. Okay, so what's in here? 1 over u, because here's u, right here. 1 over u, and the rest of it's du. I ran out of room. Okay, so the integral is, no, what did you say? What? ln. Yeah. Yeah, yeah, the integral of 1 over u, look on your, it's ln, okay? So we're going to have the ln of u plus c, but what's u? I don't know if it needs that many parentheses. I'm writing them there, but I don't know if it'll need that many. Actually, it may use absolute value. Sometimes with ln, it does that. So it might be that. Okay. All right, does that, you've got to have your rule sheet with you so that you remember, you know, what's the integral of 1 over u.
Are we in the rule sheet with the test or?
That's fine.
We'll say something else in a minute. But okay, last one I want you to work on, and it's a complete, whoa, I worked it, so I'm not going to pull it up all the way. Solve the initial value problem. And so this is the deal. It didn't write it as an integral. So it says ds dt is equal to this, and find s, and s of 1 is equal to 2. So just think about what you're given. Could you write an integral out of that? Okay. Try that. Just try working with this and see what you get. Because really, it's doing an integral and then doing some substitution. Substituting back in the s of 1 equals 2. What? Yes, you will have to find the c. Yeah. So I want you to play with it. Just think through that. Or not. Talk about, because some people got it, some people didn't. You're going on the right place? That's good. Okay, so you knew this was the derivative. So to go backwards, we're going to take the integral of that thing. I am. I'm recording. I went back. Thank you, though. Now I can't get rid of this guy. Thank you very much. Okay. All right, so we have the integral of this. Pull the 20 through, then let u be 5t squared minus 3. Take the du of that, you get 10t dt. Divide by the 10, and so we have 1/10 du equals t dt. That takes care of that and that, just like we've been doing. Okay, so that's that business. So rewrite the problem as 1 over 10 times 20, integral of u cubed du. So that, we've been doing that all night, right? So now we've got 1/10 times 20 is 2. 2u to the 4th over 4. So I've got 2 over 4 becomes 1/2. That's what happens here. 1/2, 5t squared minus 3. I just substituted back in for my u to the 4th plus c. Okay? Now, the other part of the problem said s of 1 is 2. S of 1 is 2. Well, if I let 1 go in here for t, and I put 2 here because s of 1 is 2, what am I going to be able to solve for? The c. So s of 1 equals 2 allowed me to solve for c, which allows me to go back in and put the c value right there. That's the only thing that was really different than what we've been doing. You were given it as a derivative to start with, and they gave you that little piece, s of 1 equals 2, so you could solve for c. Okay? Questions?